Hello everyone, I am Abhishek HR, working as an assistant professor in Department of Mechanical Engineering, MIT Mysore. I welcome you all to the online session on control engineering. In the previous session, you were learnt about the mathematical models and also have solved some numerical problems on mechanical systems. In today's session, I am going to explain about the electrical system. So, before going to explain about the electrical system, you have already studied two subjects in your first year, that is basic electronics and basic electricals. There you have studied two popular laws, that is one is Ohm's law and one more is Kirchhoff law. So, based on these laws, we have a concept in our control engineering. So, let us just recall these laws like Ohm's law. So, Ohm's law states that the current flowing through a conductor is directly proportional to the voltage between the 2 points. So, as per the Ohm's law, we know the condition for that is V is equal to I into R. So, based on that we have a concept here. And also the Kirchhoff's law, in Kirchhoff's law we have two types, that is Kirchhoff's current law and Kirchhoff's voltage law. So, coming to the electrical system, here as per our syllabus, the basic elements of electrical systems are resistor, inductor and capacitor. See, a resistor means it is going to regulate the flow of a current in a circuit. See here, suppose if you consider an electric circuit and the current flowing through a conductor, that is denoted by I, current in the circuit, that is I, and resistance R, and the voltage between 2 points, that is V. So, as per the Ohm's law, the standard expression, that is V is equal to I into R. V is the voltage and I is the current and R is the resistance. So, this is the one of the element of a electrical system. Then we have a inductor. In inductor, in a circuit, in an electric circuit, the current flowing through a conductor, that is I, and we have a inductance L. See, inductor is nothing but it is going to store the energy in the form of a magnetic field. So, for that the inductance, the letter denoted for the circuit is L, and the expression for the inductance is V is equal to L into di by dt. So, suppose if I want the current only, means 1 by L, the integral of V into dt. The third element of the electrical system is capacitor. So, capacitor is also like it will accumulate the energy in the form of electric field. So, for this the expression is given by V is equal to 1 by C integral of I into dt. Suppose in terms of I, suppose if I want to write in terms of I is C into dV by dt. For all three elements of the electrical systems are very much important while solving the problems. See, in your mechanical system, you have seen the like spring mass system, damper, torque, force, so stiffness of spring, like that. So, in the similar fashion, here also we are going to use the terms like instead of force we are going to use the voltage, instead of the damper position and the stiffness of spring we are going to use the current and as the capacitance. So, like that force and torque will play the major role in the mechanical system, and here voltage and current will play the major role in the electrical system. So, these are the three important elements of the electrical system. I will repeat once again, resistor, inductor and capacitor are the three main elements of the electrical system. The expression as per the Ohm's law, that is V is equal to I into R, and for the inductance V is equal to L into di by dt. And one more thing here, di by dt is the rate of change of current with respect to time, that is why I have written di by dt, the rate of change of current with respect to time. So, current flow is going to vary with respect to time. So, that is why I have written as L into di by dt. And third one, capacitor, V is equal to 1 by C into integral of I into dt. Now, let us solve some problems. So thereby we can understand in detail about the electrical system. See, before going to start the problem, I want to tell you about the Kirchhoff's law. Why? Because we are going to use the Kirchhoff law condition while solving the problems in the next steps. So as per the Kirchhoff's law, we have two types: Kirchhoff's current law and Kirchhoff voltage law. See, as per the Kirchhoff's voltage law, the voltage across the circuit is equal to the voltage in the individual element of the circuit. In the same way, for the Kirchhoff's current law, the current in the circuit, in the overall circuit, is equal to the current in the individual element of the circuit. So based on these two conditions, we are going to solve the problems in under electrical system. Okay, let us go with the problem now. Here the first problem, obtain GDE. GDE means governing differential equation, and TF, transfer function, for the system shown. See, there is a system, electrical system given, and Vi means the input voltage Vi of t, and they have given resistance, inductance and the capacitance also. Here we have I1 current and I2, and we have the output voltage V0 of t. So this is the given problem. For this we need to generate a governing differential equation as well as the transfer function. Okay, for this, as I already told, I am going to apply the Kirchhoff's voltage law. Suppose, see here, as per the Kirchhoff's voltage law, the voltage across the circuit is equal to the voltage of the individual element in the circuit. So here, as per the Kirchhoff voltage law, here input voltage Vi of t is equal to voltage of resistance VR, voltage of inductance VL, voltage of capacitance VC. See, the voltage across the circuit and voltage of the individual element VR plus VL plus VC. So voltage of resistance, that we have already known, V is equal to IR. So I have written IR, current into resistance, plus VL means resistance of the inductance. So L into di by dt, plus voltage of the capacitance 1 by C integral of I into dt. So for this I am going to apply the Laplace transform. See, I have written here Laplace transform. Just recall the basic functions. I is equal to I of S. So if it is di by dt, then it is S into I of S. Integral of I into dt means it is the 1 by S. So these are the three main basic functions of Laplace transform that we are going to use while solving the electrical problems. So the same condition now I am going to apply in the next step. So instead of Vi of input voltage, now I am going to apply, instead of t I am going to apply S. Vi of S is equal to R. Instead of I am going to apply I of S plus L into di of dt is S into Is, S into Is, then plus 1 by C integral of I into t. Instead of integral of I into dt, I can write it as 1 by S. Since I have already have C, so it is 1 by Cs. It is clear? See here, in the first step I have just applied the conditions of the voltage of resistance, voltage of inductance and voltage of capacitance. Now in the second step I have applied the Laplace transform condition. Then just here in all the three components I of S is common, take I of S as a common factor, then remaining terms are R into Cs. If we take the LCM, so it will become R into Cs plus L into Cs square plus 1 divided by whole thing divided by Cs. So this is the input voltage of the circuit. Then now in the similar way, now I am going to apply the Kirchhoff's voltage law to the output circuit here, V0 of t. See, for this I am going to consider only the capacitance since it is the output voltage. So V0 of S is equal to 1 by c integral of I into dt, I have directly applied the Laplace transform here. So, it will become 1 by cs into I of s. So, I need only I of s. So, I will just transfer this Cf's to here left hand side. So, it will become I of s is equal to Cs into V naught of s. Now, I got the value of I of s. I of s is equal to Cs into V naught of s. Now, substitute this value in equation number 1 that we have already got input voltage. So, for that just substitute the value of I of s. So, for that we will get a transfer function. Transfer function means what? The output by input, output voltage by input voltage. So, just simplify and write in terms of V naught of s by V naught of I. So, sorry, V naught of s by Vi of s. So, you will get 1 by RCS plus LCS square plus 1. So, this is the final transfer function for the given electrical circuit. So, in the similar way we can solve some other problem also. The main thing that you have to remember is Kirchhoff voltage law condition and Laplace transform. We have two voltages over here, input voltage and output voltage. So, for that condition I have just applied the resistance of the voltage of the resistance, voltage of the resistance, voltage of the inductance and voltage of the current, sorry, capacitance. So, I have just applied the condition, In the second step I have applied the Laplace transformation function. Then I have again applied the Kirchhoff voltage law to the output circuit. Then I have just modified the expressions in terms of output by input. So, thereby I got transfer function as 1 by RCS plus LCS square plus 1. So, this is our first problem. Now, we will see one more problem with a different condition. See, this is the given problem. For this also we have to find out the governing differential equation and as well as the transfer function. The question frame is similar for all the electrical circuit problem. They will give like obtain the governing differential equation and the transfer function for the given system. So, here the given system is buffer amplifier. See, before going to solve this, I want to tell you one thing, that buffer amplifier is one that provides the electrical impedance transfer which may cause some effect by the current. See, electrical impedance transformation means like to maximize the power transfer or to reduce the signal reflection from the load. So, for that that is the concept of buffer amplifier. So, in the given problem, see, there are two circuits here. It is a complete circuit, but I am going to divide into two circuits. In between we have a buffer amplifier. Here we have an input voltage. In the capacitance they have already given some value 1 microfarad, and we have a resistance 1 micro ohm because the unit of resistance is ohm. Then here I have 0.5 microfarad, again one more capacitance, then I have the resistance, one more resistance 1 micro ohm and the output voltage. Now, what I will do is I will just divide the circuit. First I will consider the first half of the circuit as my first circuit, electrical circuit, then the second one as a one more electrical circuit. Okay. Now, just consider this part, this portion. Here I have input voltage, capacitance and resistance. So, now I will apply the Kirchhoff voltage law to this circuit and also the Laplace transform function. Before going to solve this, let us just simplify these values. Okay. So, before going to solve this problem, let us simplify this value 1 microfarad. See here 1 by Cs is equal to, in place of C I can write it as 1 into 10 to the power of minus 6, that is 1 microfarad. So, into I have a S, so 1 into 10 to the power of minus 6 S. If I shift to this 10 to the power of minus 6, So it will become 10 to the power of 6. Now the value will become 10 to the power of 6 by S for the capacitance, and similarly for the resistance it will become 10 to the power of 6. So now I will just apply the Kirchhoff's voltage law to the input circuit. So Vi of S, I have directly applied the Laplace transform here, is equal to, from this circuit we have one voltage of the capacitance and voltage of the resistance. So Vc plus Vr for only this portion. Then in place of Vc, I can write it as 10 to the power of 6 by S into I of S. Why? Because instead of 1 by Cs, I have already simplified the value. So I directly write 10 to the power of 6 by S into I of S plus 10 to the power of 6 into I of S. So V I of S means in the input voltage is equal to, just 10 to the power of 6 into I of S is common factor. I have just taken the common factor outside. The remaining terms are 1 plus S by S. So input voltage is equal to 10 to the power of 6 1 plus S by S into I of S. This is the equation A. I name the equation as A. Now apply the Kirchhoff voltage law to the output circuit. Now I have applied the KVL to the input voltage. Now I am going to apply it for the output voltage, that is V1 of S. See, this is the input voltage and this is the V1, the output voltage for this circuit. So Vi of S is equal to Vi of R, only the resistance. So it will become V1 of S is equal to 10 to the power of 6 into I S. So I need the value of I of X. So I can simplify and just substitute in the place of Vi of S, equation A. If I substitute the value of I of S, so I will get the value in terms of Vi of S is equal to 1 plus S by S into V1 of S. So now first half of the circuit or the first portion of the circuit is completed, right? Here I got the input voltage of S is equal to 1 plus S by S into V1 of S. I got the value output in terms of V1 of S, input in terms of Vi of S. Okay. Then coming to the second half of the circuit, here for this circuit input voltage is V2, because here it is V1. So here it is V2. So V2 of S is equal to Vc plus Vr. Here I have capacitance plus resistance. So Vc plus Vr. So I have written. For this also I am going to simplify the values. 1 by Cs is equal to, here the capacitance value is 0.5 microfarad. So 1 by 0.5 into 10 to the power of 6. If you simplify this, you will get 2 into 10 to the power of 6 by S. And for the resistance, it is 10 to the power of 6. So just apply over in place of Vc and Vr and simplify this as like your previous first circuit. So V2 of S is equal to 10 to the power of 6 I of S into 2 plus S by S. Okay. I have just applied the Kirchhoff's voltage law for the second half of the circuit. That's it. We have a capacitance, we have a resistance. Okay. So for that they have given some value for the capacitance. I have just modified that value and I have just entered it and I got the V2, means this input voltage. So V2 of S is the input to the second half of the circuit. So I got V2 of S is equal to 10 to the power of 6 into I of S 2 plus S by S. In the similar way, apply the KVL to the output. Apply KVL to the output of the circuit, that is V0 of S, final output. So is equal to Vr. Vr means nothing but 10 to the power of 6. 10 to the power of 6 I of S. So V0 of S is equal to 10 to the power of 6 into I of S. I got the value in terms of I of S. Now I need this value, I of S value, just simplify this. So you will get V0 of S by 10 to the power of 6. Now this equation is, call it as C, and this equation is D. Okay. Now since it is a buffer amplifier, V1 of S is equal to V2 of S. V1 of S input voltage and V2 of S, that is the output voltage for the buffer amplifier. So just use the equation number 1 and equation number 2, just write the values in place of V1S and V2S. That is, what is V1 of S? V1 of S is VIS by 1 plus S by S. So here I have written S by 1 plus S into Vi of S. Similarly for the V2 of S, S plus 2 by S into V0 of S. What is the required parameter that we need to find out is transfer function. So transfer function is nothing but output by input. So V0 of S by is equal to Vi of S is equal to S square by S plus 1 into S plus 2. So this you will get once you simplify this. It's a simple procedure. Just in terms of V0 by Vi, you just simplify this, you will get S square by S plus 1 into S plus 2. So this is the final transfer function expression as per the given problem. Okay, let us see one more problem on electrical system, that is obtain the transfer function of the system shown. So here this is the given electrical circuit, we have input voltage, but here we have resistance and capacitance in parallel condition, and also we have one more resistance R2 and output voltage V0 of T. So for this we need to obtain the transfer function. See, for this system resistance and capacitance are connected in a parallel condition. So I will consider it as a Z for that area, or for the two condition I will consider it as a Z, like equivalent voltages of the resistance and capacitance in parallel series. So that is 1 by Rp is equal to 1 by R1 plus 1 by R2. This is the parallel condition. So for this, for the resistance R1, 1 by R1, and for the capacitance 1 by R2, means capacitance means 1 by Cs. So suppose if I written 1 divided by 1 by Cs, means it will become Cs. So I have directly written as C into S. So 1 by Rp is equal to 1 plus R into Cs divided by R1, and when you simplify this to Rp, means the equivalent resistance in parallel condition, that will become R1 by 1 plus R1 C into S. So I have solved these two conditions with the equivalent resistance in parallel condition. Now I am going to apply the same thing, Kirchhoff's voltage law, for the input circuit and output circuit. See here, Vi of S is equal to Z. Z means what? The equivalent condition. Z into I of S plus R2 into I of S. I have directly applied the Laplace transform. So Vi of S become Z plus R2, because I of S is a common factor. Now just apply the value of Z, R1 by 1 plus R1 Cs plus R2 into I of S. So this is the input voltage. And for the output voltage, apply KVL to the output circuit. V0 of S is equal to R2. V0 of S is equal to R2 into I of S. So in place of I of S, we can written as V0 of S by R2. So just simplifies this equation in terms of output by input. So we will get R2 into 1 plus R1 Cs divided by R1 plus R2 plus R1 into R2 into C into S. So this is the final transfer function expression for the given circuit. Okay. Now let us see the last problem in the electrical system, that is obtain the transfer function of the system shown. So this is the given electrical circuit. So for this we need to find out the transfer function. As we have solved the previous problems, so based on that, it is also a similar problem like that. So we have a two resistance over here, R1 and R2, as well as we have two capacitance C1 and C2. So for this we need to find out the transfer function. In the first step, what I will do is I will just apply the Laplace transform to the electrical circuit, then I am going to rewrite the circuit. So in place of Vi of t, that is the input voltage to the electrical circuit. So for that, if I apply Laplace transform, so it will become Vi of S. So and for the capacitance 1, C1, so what is the value if I apply Laplace transform to capacitance is 1 by Cs. Since it is we have two capacitance here, so for the first one it is 1 by C1S and the resistance R1, and for the second capacitance 1 by C2 into S and the resistance R, and we have the output voltage V0 of S. And we have a 3 loop here. The first one R1 1 by C1S and the current I1. So for this loop, for this portion I will consider as a loop 1, and for the second portion with respect to R2 and 1 by C2S it is a loop 2, and the rest of the portion at the output stage it will be loop 3. So I have loop 1, loop 2 and loop 3. For all the loop 1 and loop 2 and loop 3 I am going to apply the Kirchhoff's voltage law. Now I will apply the Kirchhoff's voltage law to the loop 1, where we have resistance 1 and the capacitance 1 and the current I1. So as we all know, the Kirchhoff's voltage law, the voltage across the circuit is equal to the voltage in the individual element of the circuit. So only if we consider only first loop, so we have voltage of the input voltage is equal to voltage of resistance plus voltage of capacitance with respect to first loop. So I have written R1 and C1, VR1 plus VC1, and if I apply the values of the respective resistance and the capacitance, so R1 into I1 of S plus, since it is a capacitance, 1 by C1S into I1S minus I1 of I2 of S. Why? Because we have two currents here, I1 and I2. So finally it will become R1 plus 1 by C1 into S into I1 of S. I1 of S is a common factor here, and we have minus 1 by C1S into I2 of S. I have just applied the Kirchhoff's voltage law to the loop 1, for the loop 1. Now what I will do is, now I will apply the same Kirchhoff voltage law to the loop 2, where we have resistance 2 and capacitance 2, 1 by C2S, C2 into S and R2. See here, now I am applying the Kirchhoff's voltage law to the loop 2. Since I do not have the voltage in the loop 2, I will consider it as a 0, and the rest of the elements, that is voltage across the resistance 2 and the voltage across the capacitance 2 and the voltage across the capacitance 1 as per the Kirchhoff's voltage law. Then I will just apply the Laplace transform function in place of these 3 elements. So R2 into I2 of S with respect to loop 2, and in capacitance 2 1 by C2 into S into I2 of S, plus I have capacitance 1 also here because it is relating with the loop 2 also. So 1 by C1S into I2 of S minus I1 of S. I have just applied the Laplace transformation in place of these 3 elements. Then I just simplify this, R2 into I2 of S plus 1 by C2 into S I2 of S, plus here I have I2 of S minus I1 of S, because I have applied for the loop 2, so the current will be I2 of S minus I1 of S. For the loop 1 it is I1 of S minus I2 of S. So I will just simplify this with respect to I1 of S, 1 by C1S into I1 of S is equal to, so if you simplify this you will get R2 plus 1 by C2 into S plus 1 by C1 into S into I2 of S. So now we have a common factor over here, C1S, and here also we are right hand side also we have C1 into S, just cancel this, and modify the expression in terms of I1 of S. I1 of S is equal to R2 into C1 C2 into S plus C1 plus C2 by C2 a whole term into I2 of S. I1 of S is equal to R2 into C1 into C2 into S plus C1 plus C2 whole thing divided by C2 in terms of I2 of S. I have just taken the LCM in this expression. So, this is the expression for the equation number 2 is the expression for loop 2. Now, I am going to apply the Kirchhoff's voltage law to the loop 3. Here it is the output voltage. So, I have only the output voltage. So, V1 of S is equal to 1 by V1 of S is equal to Vc2 because capacitance 2 is attached with the loop 3 also. So, it will become 1 by C2 into S into I2 of S. So, I2 of S become V0 of S into C2 into S. Now, what I will do? I will use the equation 1 and equation 2. So, just to modify the expression in terms of input and output voltage. So, I1 of S is equal to R2 C1 C2 S plus C1 plus C2 by C2 into V0 of S into C2 into S. So, this is nothing but in place of I2 of S I have written V0 of S into C2 into S. So, our first expression Vi of S is equal to R1 C1 S plus 1 divided by C1 of S into R2 C1 C2 S plus C1 plus C2 by C2, and also we have C2 into S into V0 of S minus 1 by C1 S into C2 S into V0 of S. Wherever we have I2 in the expression, have just apply the value of I2 of S. So, when you are going to simplify this, you will get this expression Vi of S is equal to R1 C1 S plus 1 into R1 C1 C2 S plus C1 plus C2 minus C2 divided by C1 into V0 of S. So, our input is expressed in terms of the output. This is what we required in the problem. Now, we know that transfer function is the output voltage by input voltage. So, V0 of S by Vi of S, just modify this, you will get C1 by R1 into C1 into S plus 1 into R2 C1 C2 S plus C1 plus C2 minus C2. So, this is the final transfer function for the given electrical circuit. See, you need to remember one thing, how to apply the Kirchhoff's voltage law to the respective circuit. Since we have a 3 loop in this problem, I have applied the Kirchhoff voltage law for all the 3 loops and I got the final transfer function like this. In the similar way, whatever the circuit may be, you just apply the Kirchhoff voltage law, and in some of the problems they are going to express the voltage in terms of EI and E0 also. So, with respect to that, you can find out the transfer function. Thank you.